All right, let's just jump right in. We are standing on the edge of a technological revolution that's about to redefine, well, everything. We're talking about the end of crashing computers, the end of lag, and the beginning of AI that is truly unbreakable and just keeps getting smarter.
I mean, just let that sink in for a second. And look, this isn't some far-off sci-fi dream. The projections say that by 2025, this starts becoming our reality. And it's all powered by something that sounds like it's from a movie: quantum fusion.
That's the real question, isn't it? What's the secret sauce? It's not just a slightly better chip or a clever new algorithm. Nope. It's about solving the single most fundamental problem that's holding back all of our current technology.
To really get why this is such a game changer, we first have to talk about the walls we're hitting right now. I mean, the very foundation of our entire digital world, silicon. It's pretty much at its breaking point.
Take a look at this number, 50 gigawatt hours. That is the insane amount of energy it took just to train the GPT-4 model. To put that into perspective for you, that's enough juice to power 5,000 homes for an entire year for just one training run.
And that wasn't a one-off. It's part of a huge global trend. As of right now, AI data centers are already guzzling down 2% of the world's entire electricity supply. There's just no way we can keep this up. We can't power the future of intelligence on yesterday's grid.
And it's not just the energy bill, right? We're smacking into hard physical walls. Silicon literally melts when we push it too hard. Moore's Law, that engine of progress for decades, it's pretty much stalled out. And our power grids are so fragile that a whopping 40% of data center failures are caused by simple power surges. Imagine a months-long AI training run getting wiped out by a brownout. It happens all the time.
So, here's the bottom line. Our current approach to power is like trying to explore the universe with a flickering candle. It's just not going to cut it. What we need is a sun, a constant, limitless, totally reliable source of energy.
And that is exactly where quantum fusion comes in. Now, this isn't the kind of fusion you've seen in old sci-fi movies. This is something much smarter, way more efficient. It's a practical way to harness the power of a star, right here on Earth.
So how on earth does this work? Well, it all comes down to this tiny but mighty particle called a muon. Think of a muon as a super heavy electron, like 200 times its mass. And when you get a muon to replace an electron in a fuel atom, that extra weight pulls the whole atom in super tight, shrinking it way down. This is muon-catalyzed fusion, and it is the absolute key to making fusion happen without needing the insane heat of the sun.
It's like this incredible little atomic dance. First, the muon swaps in, shrinking the atom. Second, because it's so small, it can get incredibly close to another fuel atom. And third, this is where the magic happens. They're so close, they can do something called quantum tunneling. Instead of trying to climb over this huge energy wall that keeps them apart, they just phase right through it, like a ghost through a wall. They fuse, and bang, a huge burst of energy. And the best part? The muon is set free and zips off to start the whole chain reaction all over again.
And this process is ridiculously fast. We're talking prototypes from MIT that are already hitting 1 million fusion reactions every second for every single gram of fuel. The energy density is just off the charts. This is where you really see the leap. Our best solar panels, which are great, convert about 20% of the sun's energy into electricity. Quantum fusion? A massive 60%. It's not just a little better, it's in a completely different league. It's just fundamentally more efficient.
And this is the mic drop moment for fusion energy. Commonwealth Fusion Systems' Spark reactor has officially hit a Q value greater than 10. That means it is producing over 10 times more energy than it consumes. This is it. This is proof that self-sustaining fusion is real. We're talking about a star in a box, ready to power not just our AI, but our cities, cleanly and forever.
Okay, so we've got a star in a box. We have limitless, clean, efficient power. So what do we do with it? Well, now we build the impossible. We build an immortal machine, a computer that can literally heal itself.
And this is the perfect way to think about it. You know, when you get a cut, your skin just heals. You don't have to think about it. That's what this new hardware does. Powered by that constant fusion energy, it uses these nanoscale processes to rebuild its own circuits in real time.
Let's just put these side by side, because the difference is, well, it's night and day. Uptime, we think 85% is decent for a classical system. The fusion-powered AI, 99.9999%. It basically never goes down. And it's not just reacting to failures. Our old systems are brittle. These new ones heal over 100,000 potential faults before they even happen. They don't wear out, they just keep running forever.
And if you think this is all just theory, you gotta hear this. A DeepMind chip, powered by a prototype reactor, healed 100,000 faults from radiation while it was still running. Xanadu's photonic chips, they ran for over 1 billion operations straight without a single recalibration. This is happening right now.
So what happens when you plug this immortal machine into the world? Well, the future starts arriving, like, right now. The breakthroughs are already rolling in faster than we can even keep track. Let's just look at a few quick flashes of what this looks like. In medicine, an AI that never sleeps, never gets tired, can analyze a medical scan with a precision that's frankly superhuman. We're on the verge of diagnosing 95% of rare diseases from just one image, almost instantly.
On our roads, imagine autonomous cars that don't just follow the rules, but evolve together as a single fleet. Every car learns from every other car's experience, all at once. The projections are a massive 80% cut in accidents.
And in science, we can now simulate a quadrillion molecular interactions an hour. This isn't just crunching numbers. This is discovering dozens of new cancer-fighting drugs in a matter of weeks, not decades. We're accelerating the pace of discovery itself.
So we are at this incredible moment. We've basically solved the fundamental problems of power and fragility. We've built an intelligence that can learn, grow, and repair itself. Forever. The old limits are just gone. Which leaves us with a new and much more exciting question. Now that we have an immortal problem solver on our hands, what monumental challenge should we ask it to tackle